Give me the definition for current.
Current, present time, occurring, existing, or belonging to the present moment.
No, not that one.
Current, directional flow of water from one location to another.
Not that one.
Current, the flow of electric charge or electrons through a conductor such as a wire measured in amperes.
So apparently we have different types of current, but my focus is on electric current. Let's get into it. Yes, people, welcome to Teaching Myself Electronics. My name is Elect. This is episode 8, Understanding Electricity Part 2, Current. So in part 1, I did give a quick overview of what current is, and that current is the flow of electrons through the wire. And I remember that easy. I just think about a hose and the amount of water coming through the hose. Less water means less flow, more water means more flow. Same thing with current. Another good example would just be think about the sea, the ocean, the beach, and you know there's current in the sea, right? Not current that will shock in the sea. It just means that it's a directional flow of water from one location to another, as described earlier. And this current in the sea is created by wind, water density, and tides. So thinking about water and current, it just reminds me easy that current, electric current, actually flow because water flows. So it's an easy match. So I already know that voltage is the push or the force of the electrons, right? Here in this diagram, you see I have current on one side and voltage on the other side. So voltage is the push, current is the flow, and this battery is holding a charge of electrons. But the electrons will have nowhere to go until we complete a circuit. So once we complete a circuit from the negative and the positive side, the voltage will create the push, and the current will cause the electrons to flow, and the charge will light up the LED or the light bulb. I'm going to demonstrate that with a simple circuit using a battery and an LED. Alright, simple circuit. A LED soldered to a perf board of a 9-volt battery, connecting a black and a red wire, red to the positive, black to the negative. Also have a resistor between the battery and the LED to prevent the LED from burning up. Because previous lessons I learned that I need only 2 volts from a 9-volt battery to light up this LED. So as you can see here, every time I connect the positive wire together, it completes the circuit. Electrons flow, the charge lights up the LED. Once I remove it, no light, it breaks the circuit. So it's simple as that pretty much. And with the resistor, I have some resistance happening here, and that's where I'm going to discuss more about Ohm's law and what I learned about Ohm's law and how important it is to figure out what voltage, what current, what resistance you need when you're doing a circuit. So earlier I said voltage and current work together to bring the charged electrons through the wire to the light bulb or the LED to light it up. But overall, voltage, current, and resistance work together. And this is what Ohm's law is. It's the fundamental relationship between voltage, current, and resistance. And resistance pretty much limits the amount of current and causes a drop in voltage. So it limits the amount of current going through the circuit. So for the Ohm's law formula, is a simple triangle that displays the 3 letters V, I, and R. And now I forgot to mention that current is actually represented by I and not C. So V for voltage, I for current, R for resistance. And what this triangle is showing right now is that we have V at the top, I and R at the bottom. So we have a denominator and a denominator. And basic maths, you know that that's division. Whereas I beside the R, you know that's multiplication. So if you want to find V, you know that it's always going to be the I times the R. If you want to find current or resistance, you know it's going to involve division because the V is at the top. A simple way that I saw on how to find which property you want to find, whether you want to find volts or current or resistance, you just cover the letter. So for example, if you want to find V, you cover the V and you know that it's I times R. If you want to find current, which is I, you cover the I and you know it is V divided by R, and vice versa. It's pretty simple. So far I found this to be simple, and this chart is very helpful as well. But I think when I reach resistance, and I'm glad resistance is left for last because I think that's where I'm going to be using this triangle this Ohm's law formula a lot when I have to decide what size resistors to use for the projects that I'm going to use. So yeah, looking forward to that. Okay, I guess it's safe to say I understand voltage, current, and Ohm's law so far, but I need to understand how to measure current. And what I found out lately is that measuring current is not the same as measuring voltage. Because measuring voltage, you have the black probe, the red probe, red to positive, black to negative, put it on the DC volt and you measure. That's not how you do it with current. Totally different ball game. All this time I had no idea that measuring current is different than how you measure voltage. Current is measured in amperes or amps for short, and if you measure it the same way as voltage, it can create a short circuit and damage your multimeter. So as you can see what I'm doing here with the multimeter, I have the dial turned to DC voltage and I'm just testing the amount of voltage that's going to the LED from the 9-volt battery. So like I said, simple black probe to negative, red probe to positive. And if you have the black to the positive and the red to the negative, it don't matter, you just get a negative value on the multimeter, which is fine. So this chart right here breaks down how you properly test current and how you should not test current. So the way to test current pretty much is to break the circuit and then allow the current to flow through the multimeter and give you the reading in amps, milliamps or amperes, right? I must admit this confused me to figure it out because I was making a simple mistake that I'm going to demonstrate. So right here I have the same perf board with the LED and the battery, and I'm just going to see how to properly test current using my multimeter. So yeah, simple circuit, red connecting to the hot to the battery, the black connecting to the negative going back to the battery as well. So I'm just going to give it a quick test to make sure that we're getting current flow to light up the LED. Yeah, so there it is. Every time I touch the wires together, I get light, which means the current is flowing through the circuit. When I remove it, the circuit is open, or I break the circuit and I have no light. This is how I would actually go ahead to test current now, by breaking the circuit, removing the wires, and then connect the multimeter in between. Yeah, it sounds easy enough, but it was not always this easy until I actually understood it. So I understand that to test current, you break the circuit by removing the positive side from the source or from the battery and connect it to the red probe on the multimeter. Also, the multimeter should be connected into the fuse connection, into the milliamps or the amps connection, and not in the volts connection. So removing it from the red connection that's marked volts and ohms for testing, we need to put the red probe into the white or yellow probe as seen on my screen here. So the yellow probe is for amps, the white one that says fuse is for milliamps. So I'll be testing an LED, so milliamps should be good enough. So I'm going to move the red probe over into the white connection. And that's now the positive from the battery will connect to the red probe on the multimeter. Alright, so I have the circuit fully connected now. The LED is lighting up. Multimeter is on amps, turn it to 20 milliamps. Red probe is connecting to the white connection for milliamps on the multimeter. And now I'm going to connect the red probe to the source or to the wire coming from the positive on the battery. Alright, so the problem I was having, I understand that the red connection from the positive on the battery will connect to the red probe on the multimeter, right? But the black connection to the black wire on the LED, when I was thinking about breaking the circuit, I was breaking both sides. I was removing the connection on the black wires and I was also removing the red wires. So when I removed the red wire, right, from the positive on the battery, and I connect that to the red probe, then I did the same thing from the black side. I was saying, all right, I have too much wires now, where should these go? So it was a bit confusing as to how to set up the multimeter so that the current runs through it. And this is a bit probably a common mistake that beginners make. Also, while trying to figure this out, I noticed that no wires should be left unconnected, because if the current is going to run through the multimeter and give the reading, everything should be connected. So after doing some madness, I took a step back I got a whiteboard and I say, all right, let me see exactly how to do this properly and the correct way. So I have two drawings on this whiteboard. I have one with the multimeter breaking the circuit that's on the left, that's a bigger image, and the one on the right is the current simple circuit that I have with the LED connecting directly with a wire to the battery. So right now I have the negative side and the positive side, and on the left side I have a resistor that's a 9-volt battery. So the 9 volt with a resistor just to prevent the LED from burning up. So that's why I have that there. So right now, currently this is the basic circuit right now. And to break the circuit, I already know that I have to break it from the source, from the positive side connecting to the battery. So I'm going to simply break right here at the battery, and I'm going to connect the red probe from the multimeter onto the source. So let me just quickly draw a multimeter here. Yeah, I know it look like a face, but it should work. All right, so the red probe is going to go all the way back to the amps connection, and then the black probe, and this is where I didn't understand where the black probe to go. But looking on this diagram, it's pretty straightforward. The black probe is simply going to go to the positive on the LED, to the load. So right now, based on how much amps or milliamps the LED is pulling, it's going to pull it through the multimeter, and we should be able to get that reading now. Alright, so this other diagram on the left now is just showing connection with the multimeter already breaking the circuit. So if you can look, we have the battery, I have the positive there, and the positive going back to the multimeter positive, right? So positive going back to the red, and then on the left side of the multimeter I have the minus, and that's the black probe of the multimeter. But on the LED on that diagram, that side that the multimeter is going to is actually the positive of the LED, because if you look on the other side of the battery where it's a minus, the minus goes all the way back to the LED negative leg, right? So this is how it should be. And this is what was confusing me, mainly because of color codes. I was matching black to black, red to red. I was looking at it. Before I did the diagram to make it more simple, I was saying what the black probe should not be going to the red on the LED. Black should go to black. And again, I think that's a simple mistake that a lot of beginners make. But looking at this diagram, it's pretty straightforward, and this is how you properly break the circuit so that the current runs through the multimeter to get the amperage reading. Alright, I'm going to take it back to the perf board and the LED and see if I can get a proper reading. Alright, let's go now. So I have the red wire coming from the positive on the battery. I have a multimeter ready. I'm just quickly reset it. Connection, red probe is in the milliamps connection. Dial is turned to 20 milliamps. Red connection from the positive, red probe on the multimeter, connect that. And then now I'm going to get the black probe from the multimeter that's connected in COM, right? I don't normally change that. And now I'm going to put it onto the positive side of the LED, and there you go. I have light on the LED, and I have 3 milliamps showing on the multimeter. And this is how you properly break the circuit, connect the multimeter, test for amperage. So the current is running through the multimeter right now, and I'm getting a reading of 3.07 amperage. Brilliant. Alright, so we know that we measure current in amps. Amperage, amps for short, milliamps, which is a smaller unit. But what is amperage really though? It essentially just measures the volume of electrons passing a specific point per second. And I always think about an analogy where you have a car on a highway, and every time like a car would go around a roundabout and it would go across a bridge, for example. Every time it passed that bridge, that would be like 1 amperage, like 1 cycle. So pretty much that's how I think about it, amperage. And then with amperage, you have different levels of amperage. With this LED, I got only 3 milliamps, right? Which is a smaller unit. With different devices, we have different amount of amperage, different amount of milliamps to amperage. And this is where AC and DC current comes in. This was another topic in electronics that I didn't clearly understand. Yes, I always hear the term AC, DC, and I always know that it's alternating current and direct current. But I never actually had a reason to think about it, which is basically DC current flows in only one direction. Hence the name direct current, DC current for short. And common uses of DC current will involve like laptops, cell phones, overall electronic devices use DC current. For AC current, alternating current, this current repeatedly changes direction. The voltage alternates between positive and negative many times per second. So this type of current you will find mostly being used in buildings, wall outlets in homes, power grids, and all that stuff. So overall, for teaching myself electronics, I will be using and be working a lot with DC current. It's good to know the difference between the both, because this is also important when using the multimeter to select the right options so you get the proper reading. So I think this should be good enough coverage for intro into current so far. A lot more to cover, but I think this will definitely help in my journey in learning electronics. Just scratching the surface, I know, but a lot more to come as we go on, one step at a time. Yeah, and I have to say, I learned a lot. I learned what current is, AC, DC. I learned how to measure current properly, how to use a multimeter to test for amperage. Yeah, it's been a nice little journey so far, and I'll just keep going. For the next step, we're going to be looking at resistance. And I've mentioned resistance a few times already. So easy. We know what resistance is. But what the trick is to actually use Ohm's law to find out the actual resistance that we need to use for each circuit that we're working on. So that one going to be a very interesting episode. So make sure not to miss that one. Remember to drop a like, subscribe, help build the channel, help build the community. So yeah, thank you for staying till the end of the video. My name is Lex. So until next time, big up yourself. Peace out.